Hello. I am Cesar J. Carvajal.
And I am Sarah Jane Molina, and we're going to discuss about greatest common factor.
What are you looking at? What? What are you looking at?
Good morning, students. I am Cesar J. Carvajal, and we are going to discuss about the greatest common factor. Before that, let us have first an activity. Kindly get some sheet of paper, or you can comment directly your answer in the comment section. Activity 1. The instruction is find the greatest common factor of the two numbers shown. Number 1 is you need to find the greatest common factor of 10 and 5. And also number 2, find the greatest common factor of the 54 and 22. Number 3 is find the greatest common factor of 10 and 20. Number 4, the greatest common factor of 6 and 3, and also number 5, the greatest common factor of 4 and 2. Okay, let us check your output. So the number 1, the greatest common factor of 10 and 5 is equals to 5. So number 2, the greatest common factor of 54 and 32 is 2. And number 3, the greatest common factor of 20 and 10 is equals to 10. So in number 4, the greatest common factor of 6 and 3 is equals to 3. And lastly, number 5, the greatest common factor of 4 and 2 is equals to 2. Now let us move to our topic, which is the greatest common factor, and also known as the GCF. Our lesson objectives for this session is, at the end of the lesson, the students will be able to understand the Euclide's algorithm in finding the GCF. The greatest common factor, or known as GCF, of two or more numbers is the greatest numbers among all of the common factors of the given numbers. The greatest common factor, or GCF, of two natural numbers, which is x and y, is the largest possible number that divides both x and y without leaving any remainder, or the remainder is 0. To calculate the greatest common factor, there are three common ways: the division, the multiplication, and the prime factorization. Can be the same as greatest common divisor. Step 1, list the positive factors of both a and b. Step 2, list the common or the positive factors of a and b. Number 3, pick the largest in the list of common factors. Let's have some examples. Finding the greatest common factors of 12 and 28. So in finding the greatest common factors, let a is equals to 12 and b is equals to 28. In our step 1, list the positive factors of both a and b. So a is equals to 12 and b is equals to 28. So these are the following factors of 12, which are 1 times 12 is equals to 12, 2 times 6 is equals to 12, 3 times 4 equals to 12, 4 times 3 equals to 12, and 6 times 2 is equals to 12, and 12 times 1 is equals to 12. So those are the following positive factors of 12. The positive factors of 12 are these following: 1, 2, 3, 4, 6, and 12. It's because when 12 is divided by those numbers, the remainder is 0. And for b, which is b is equals to 28, positive factors of 28, which are 1 times 28 is equals to 28, 2 times 14 is equals to 28, 4 times 7 is equals to 28, 7 times 4 is equals to 28, 14 times 2 is equals to 28, and 28 times 1 is equals to 28. So those are the following positive factors of B. So now on our step 2, list the common or the positive factors of A and B. So the common factors of A and B are 1, 2, and 4. Step 3, pick the largest in the list of common factors. Looking in the list that we have 1, 2, and 4. So the greatest common factor in the list is 4. Moving on our example number 2, we will find the greatest common factor of 240 and 330. So first step is let A is equals to 240 and B is equals to 330. So list down those positive factors of 240 and also the positive factors of 330. So the positive factors of 240 are this following. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 12, 15, 16, 20, 24, 30, 40, 48, 60, 80, 120, and 240. And the positive factors of 330, which is our B, are 1, 2, 3, 5, 6, 10, 11, 15, 22, 30, 33, 55, 66, 110, 165, and 330. So the positive common factors of A and B are 1, 2, 3, 5, 6, 10, 15, and 30. So finding the largest or the greatest common factor of the two number, which is 30. So the greatest common factor of 240 and 330 is equals to 30.
In order for us to easily identify the greatest common factor of two integers, we will use Euclidean algorithm. So Euclidean algorithm is a very beautiful and efficient way in finding the greatest common factor of two integers. So how to find greatest common factor using Euclidean algorithm? So let A and B be integers and A is equal to BQ plus R for some integers Q and R. Q here represent as quotient and R here is represent as remainder. Then the common factor of two integers, which are the A and B, are exactly the same as those of B and R. In particularly, it can be written as greatest common factor, the quantity of A and B is also equal to greatest common factor, the quantity of B and R. Examples in finding the greatest common factor using Euclidean algorithm. To find the greatest common factor of 330 and 240. So in order for us to be able to identify easily the greatest common factor, let's create 4 columns. So these columns consist of Q, A, B, and R. So now, let's take these two numbers, 330 and 240. So which do you think is the bigger number? 330, right? Since 330 is a bigger number, let's use 330 for our A and the next number for letter B. 330 here and 240 here. So now, do the division operation. Whenever your B is 0, then whatever there in A, so that would be your GCF. So let's now divide 330 divide by 240. So the answer would be 1 and 240 here. So 330 minus 240, the answer would be 19. So here, this is your quotient. And here is the remainder. So 1 here and write 90 here in the R column. In our first row, we are done. We will proceed to the second row. So we will proceed to shifting operation, which means our B here becomes our A, so 240. And our R here becomes our B. And after that, repeat the division operation. So 240 240 divided by 90, the answer will be 2. 2 times 90 becomes 180. 240 minus 180, what would be the answer? 60, right? So this is the quotient, and this is the remainder. So we will write 2 here and 60 here. So do another shifting operation. 90 here will become our A, and 60 here will become our B. So let's write 90 here and 60 here. So again, repeat the steps. Do the division operation. So 90 divided by 60, what would be the answer? 1. So 1 times 60 will be 60. Then minus 90 minus 60, 30. So 1 is our quotient and 30 is our remainder. So we will write 1 here and 30 here. Then proceed to shifting operation. It will be 60, 30. So do again the division operation. 60 divided by 30. What would be the answer? 2, right? 2. 2 times 30 will be 60. And it becomes, the remainder becomes 0, right? So we will going to write 2 here in the quotient and 0 here in the remainder. So are we gonna stop there? No, because as I said a while ago, your B value here would become 0. And whatever there in A, so that would be our GCF. That means whatever value there in A, so that would be our GCF. So let's do the shifting operation again. So here would be 30 and here become 0. So let's do division operation. 30 divided by 0 is undefined, right? So it's undefined. So let's write x here since it's undefined. So we can now have the GCF since our B here is 0 and A here is 30. So we will write GCF 30, 40, and 30. Do you understand, class? Let's have a real-life example in finding the greatest common factor using Euclidean algorithm. So here's the problem. Heather is a project manager and you need to schedule the timeline for a new product launch. The product has 2 different components, A and B, and each component has its own product time. Component A takes 240 hours and component B takes 360 hours. To determine the longest duration that these 2 components can be produced simultaneously. So let A will be 360 hours because 360 is bigger than 240. So since we already know that 360 hours is our A, let's now write 360 for our A and 240 for our B. So let's now proceed to division operation. So 360 divided by 240, so the answer would be 1. And the remainder for that is 120. And we will now do the shifting operation, which now our 240 here will be our A and 120 will be our B in the shifting operation. So we will now proceed again to division operation. So 240 divided by 120, the result will be 2. And the remainder will be 0. So since our B here is not 0, so we will proceed again to shifting operation. So our B here will become A. And our remainder here will become our B. So 120 divided by 0, since we will proceed to division operation. So 120 here divided by 0, it can be undefined. So since it's undefined, we will write there x and the remainder will be x. Since our B here is 0 and our A here is 120, therefore our greatest common factor of these two, 360 and 240, is 120. So the greatest common factor is 120. So here, the greatest common factor of 360 and 240 is also equal to the greatest common factor of 240 and 120. Therefore, the greatest common factor of 360 and 240 is equal to 120. So that would be the end of our discussion. Thank you for listening. And